Alright, we're taking a look at our exponent rules assessment, so we're just going to go through each problem here. You can go ahead and fast forward to any of the problems that you need to see, come back and see them again if you need to, and we'll just kind of go through them. So we're starting here at number 1. It says, first of all, that if the number is given in standard form, write it in scientific notation, and if it's given in scientific notation, write it in standard form. So number 1 here is written in standard form. And so I'm going to put this number into scientific notation. So currently in standard form, if there were a decimal in this number, it would go right here at the end. And so by putting this in scientific notation, I have to make it be a number that is between 1 and 10. And so I have 4.18 times 10, and then I have to figure out how far I moved my decimal point. So notice that I have put my decimal point after the 4 right here, but originally it started after this last 0. So if I go ahead and count from where I put it to where it was located, I'm going 1, 2, 3, 4, 5, 6 places to the right. So times 10 to the 6th is going to be my exponent there. Okay, number 2. We're looking at a number that is in scientific notation, and I want to write it in standard form. So I want to write it as either a decimal number or a number that's going to be maybe in the thousands or hundred thousands, millions, and so on. So my exponent, because it is a -4, it's telling me that I am going to move my decimal point to the left. So I'm taking my number 2.73, and I am going to move my decimal point 4 places to the left. So 1, 2, 3, 4. I've moved it to there. And then notice that each of these dips, there's nothing there right now, but I need to put some zeros in there. So I would go ahead and put a 0 here, a 0 here, a 0 here, and that gave me 3 zeros. And I have now written this number in standard form. For 3 and 4, it says perform the given operation, write the number in scientific notation. So I need to take these, I'm just going to go ahead and put a line here to separate the two problems first. I need to take these two pieces and I need to combine my like parts. So I've got 5 times 7, and then I've got times 10 to the 6th times 10 to the -8th. And so I can go ahead and I can multiply my like pieces here. I've got 5 times 7, that is the number 35. And then for my other like pieces, I've got 10 to the 6th and 10 to the -8th. And I can go ahead and write that as my exponents being added together. So right now I've got 35 times 10 to the -2nd. And I'm almost done, except this number 35 right here. It's not a number that's between 1 and 10. So technically, I don't have this in correct scientific notation yet, but I can make it be that way. So I'm going to make that number 35 into 3.5 times 10, and then I got to figure out, I've got a -2 that's already there. And so my decimal point was here. I chose to put it here. To get back to the original, I'm going to the right one, so I'm adding 1. And so this would really be 3.5 times 10 to the -1st. Okay, over here in scientific notation, I'm taking 9.6 and I am dividing, let's see, 9.6 times 10 to the 7th, first of all. So I've got my number divided by my number, and then I've got 10 to the 7th divided by 10 to the, and I can't quite see what that number is, 10 to the 4th. So when I divide 9.6 by 1.2, I get just the number 8. And then I've got times, and for 10 to the 7th over 10 to the 4th, if I wrote this all out, I'd have like 10 times 10, 7 times, right? Okay, and I kind of ran out of room there. Over 10 to the 4th would be 10 times itself 4 times. And then I would look at what can cancel, and I can take a 10 divided by a 10 and a 10 divided by a 10 4 different times because that's going to be a 1. And so I'm really left with 10 times 10 times 10, which is times 10 to the third. And so a shortcut that we can kind of see here for division is that I could really just have taken 10 to the 7 minus 4 power, and I get 8 times 10 to the third. Okay? All right. For 5 and 6, we're talking about the power rule. And for number 5, it wants us to explain what the following expression means and do not simplify. So I have h squared, that term cubed. And so what that means is that I'm going to take h squared and multiply itself three times. And so you would have h squared times h squared times h squared. That's what it means, okay? So then for number 6, it wants us to go ahead and actually simplify, and I've got x to the 5th 6 times. So that means to take x to the 5th times x to the 5th times x to the 5th times x to the 5th, 6th of those. And then if I were to go ahead and multiply this out further and keep simplifying, x to the 5th means x times x times x times x. And so if I did that, I've got 5 of them here, 5 here, 5 here, and so on. And so I've got 5, 10, 15, 20, 25, 30. And so we see for the power rule that I could have gone ahead and just taken x to the 5 times 6 power, and I would still get my x to the 30th. All right, for 7 and 8, again, I'm going to go ahead and draw my line here down the middle. For number 7, we're using the product rule here, and we want to have positive exponents. So for this one, I've got b to the 7th times b to the 9th. And again, if I were to write this out, I would just have b times b times b times b 7 times. And in this one, I would have b times b times b 9 times. And so if I were to count up how many total there are, I would just have this rule right here. B times itself 7 times, b times itself 9 times, add them all up, and I would have b to the 16th. So for the product rule, we're actually adding our exponents to get to our answer. Now, the same thing applies for number 8, even though I've got some numbers, then I've got some x's, then I've got some y's. Remember that we want to keep our like pieces together. So I can go ahead and I can take 2 times 4, because remember, this whole entire thing right here is one kind of really large multiplication problem. So I've got 2 times 4. I've got x to the 3rd times x to the 3rd. And then I've got y times y squared. So I'm going to put all my like pieces together, and then I'm just going to do what it says. So it tells me to take 2 times 4. I'm just multiplying, and I get 8. Here, I'm multiplying, but it really tells me to add my exponents, because x to the 3rd is x times x times x, and another x to the 3rd is x times x times x, and you're going to get 6 of them, so we're just adding our exponents, and here I've got y to the 1 plus 2 power. And so to simplify this, I've got 8x to the 6th, y to the 3rd. Okay, so the quotient rule. Number 9 was kind of a tricky one for us. For some reason, I'll go ahead and split this down the middle. But just like we just did on number 8 with, just like we did with number 8, we put our like pieces together, our numbers with our numbers, x's with x's, y's with y's, and so on. I'm going to do that same thing. And so I'm going to separate this out. I've got 5 over 10, and that's just a fraction. If there were no x's and y's at all here, I would be able to simplify this fraction just as a normal fraction. Then I've got x over x squared, and then I've got y to the 3rd over y. So again, I'm gonna simplify this just as a normal fraction. If I didn't have any other x's or y's, 5 over 10 is the same as 1/2. It's just a fraction that I went ahead and simplified. Now, we don't always have to write this out, but if we're having trouble, we can. X squared means x times x. Now remember that something divided by itself is 1, and these things are going to cancel out for me, and they're going to not be there. So right now, if I were to stop, I would have 1 over 2x. But then I have to look at this y term, and so if I simplify this out, I've got y times y times y over 1y, and again, one of these things will match up, and they will cancel out, and I'm left with y times y, which is going to give me 1y squared over 2x for the bottom. Okay? Now, hopefully we could kind of see here that like if I took this piece right here and I just looked at the exponents, it would tell me y to the 3 minus 1 power is going to give me that y squared right here. Okay? So you don't have to write all of these out every time, but if it helps you see what will cancel for each of your fraction pieces, go ahead and write them out. It won't make it wrong. Okay, so number 10. Again, I'm just going to separate out the pieces that are alike. And notice that when I get over here to y, there's nothing that is a y term to put on top of it. So it's not going to cancel with anything. It's just part of my fraction that happens to be hanging out on the bottom. So the first thing I'm going to do is I'm going to simplify this fraction. 4 over 6, I can take a 2 out of each. 4 divided by 2 is 2. 6 divided by 2 is 3. Then I notice, okay, right here I've got x over x. Those are both going to cancel, so there are going to be no x terms in my answer. And then for the y term, it's on the bottom. It's staying on the bottom. There's no reason to change it. There's nothing that will cancel it. And so I'm done right there. All right, 11 and 12 were the two kind of most missed problems on the quiz. So we want to take a look at that. We have, for number 11, we have this thing in the parentheses is being squared. And so we talked about that everything inside of this parenthesis is going to be squared. So I can either simplify inside of the parentheses first and then square everything, or I can square everything first and then simplify. I'm going to go ahead and choose to square everything first and then simplify. So I'm just going to rewrite everything as it is being squared. So I'm going to have 2 squared. I'm going to have x to the negative 4th squared. So I'm taking that times 2. I'm not squaring it because remember, this means if I just had x to the negative 4th and I wanted to square that, it means that I'm taking x to the negative 4th times itself 2 times. And so I would actually add those exponents together. I would not square it and make it to the positive 16. So back to this, I'm going to have y, and since I just have a y there, it's going to be squared. On the bottom, I have 4 squared, I have x squared, and I have y to the negative 3rd squared. So we can go ahead and simplify that. 2 squared is 4, x to the negative 8th, y squared, over 16 x squared, y to the negative 6th. So now I'm going to go ahead and separate this out into my different pieces. And I'm actually going to do something here so that I don't have any negative exponents because it says right up here, write your answer with a power, as power with positive exponents. And so since this guy right here, this x to the negative 8th, it's a negative exponent and it's in the numerator, I can just move that to the denominator and I would have a positive exponent. And notice that I don't have any x terms then that are left on the top of my fraction. Okay? Now, same with the y term. I've got my y squared, which is a positive exponent, so it's staying put on the top. But then when I look at my other y term, it's a negative in the denominator. I'm going to move that to the top and I'm going to make it positive. So when I go on and I simplify my fraction here, I've got 1/4 times, in the denominator, I've got x to the 10th power because those are both x's and I'm going to add those exponents. And then for the y's in the top, I've got y to the 8th. So here is my total final answer, 1y to the 8th over 4x to the 10th. Okay, so number 12 is similar. I'm going to do the same exact thing as I just did in number 11. This one is a little bit better because I don't see any negatives, so that's nice. But I'm going to get 4 to the fourth, x squared to the fourth, y to the fourth, over 3 to the fourth, x to the fourth, y to the 0 times 4. So when I go ahead and simplify here, I get 4 to the fourth, that's going to be 4 times 4 times 4 times 4, that's 256, x to the eighth, y to the fourth, over 3 to the fourth is 3 times 3 times 3 times 3, that's 81, x to the fourth, y to the 0. Now at this point, we remember that anything to the 0 power is just a 1, or it's like it's not there. So now I don't have to worry about that piece. I'm going to separate out my like pieces. I've got 256 over 81 times, I've got x to the 8th over x to the 4th. And then I've got just y to the 4th over, and there's nothing on the bottom for y to be with. So when I go to look at my fraction here, and I try to simplify it, I notice, nothing will simplify out of that. It just is what it is, times. So on this one, I'm going to go ahead and subtract my exponents because I've got 8 of them in the numerator, and I've got 4 of them in the denominator. So I know that 4 of them are going to cancel. The 4 that are in the denominator are going to cancel with 4 of those 8 that are in the numerator, and I'm going to be left with 4 of them left. And then I've got the y to the 4th that was already there. And so I've got, as a final answer here, 256 x to the 4th, y to the 4th, over 81. And that's what we've got. Then our last problem here, I had a typo. It should be number 13, but it says number 11. Okay, it says, explain to the student who made the following error how to fix their mistake and what exponent rule they were using incorrectly. So as I look at this, to get 4 to the 4th, it looks to me like they did 4 to the 3 plus 5, and that got them 4 to the 8. And then they had this 4 squared on the bottom, so then they went ahead and divided those and got 4 to the 4th by taking 4 to the 8 divided by 2 and got 4 to the 4th. Okay, now here's what they should have done. They were more than correct in adding those together and getting 4 to the 8th. And then when they had 4 squared on the bottom, they should have actually at that point just subtracted and gotten 4 to the 6th. Okay, so there's a little rundown on our quiz. Hopefully that helped you make some corrections. You can go ahead and do the rehab and be ready for a retake if you need to.